Hi class, today we're going to be talking about trigonometric integrals. And we're going to start off with the ones that we know. We know one, that the integral for sine x dx is equal to negative cosine x plus c. The second one we know is that the integral of cosine x dx is equal to sine x plus c. But the first one we don't know is the integral for tangent x dx. What is that equal to? We're going to investigate this using the first two antiderivatives or integrals that we know. So the way we're going to do this is we're going to break up tangent into its two functions, sine and cosine first. When we do this, we will get a new integration, and since we've learned about u substitution, we're going to let u equal the denominator. So in our case, u is equal to cosine x. So our du dx is equal to negative sine x dx. Sorry, negative sine x. If I multiply by dx, then I get du equals negative sine x dx. And then if I divide this over, divide by negative sine x on both sides, then I'll get what dx equals. Dx equals du over negative sine x. And I can replace this quantity for our dx. So this will go right into there. So I'll have du over sine x, negative sine x. And then we'll have sine x over cosine x multiplied by that expression. When I do that, these sine x's cancel. Remember that u is equal to cosine x, so I have 1 over u du, and don't forget the negative. This negative is a negative 1, and that quantity can go all the way outside the integration because it's a constant, so I have a negative 1 out here. Okay, now that I have it written this way, it's really easy to integrate. We also know the integral for 1 over something is ln of that thing. So we have ln absolute value of u with a negative 1 on the outside plus c. And so our answer for the integral of tangent x is negative 1 ln absolute value of the u quantity. The u was cosine x from our red function over there, plus c. And there you have it. That's our first trigonometric integration for tan x. Okay, next one that we're going to be investigating is the integral of cotangent x dx. This will be similar to the integration for tangent. We'll break it up the same way. We'll break it in terms of sine and cosine. So now we're going to have cosine x over sine x dx. Our u is now going to be equal to our new denominator, which is sine x. So du equals cosine x dx. So if we rewrite this expression, we get the integral of cosine x over sine x times du over cosine x. These guys cancel. We get 1 over u du is our integration, and we get ln absolute value of u plus c. But now our new u is sine x plus c. And those are our first two antiderivatives or integrals for sine and cosine. Tangent and cotangent. So I'm going to fill those in. Those are our new properties. So anytime I have cotangent, I have ln absolute value of the sine of that same domain. Make sure that these two domains match when you do this. That's a domain and that's a domain. Plus c. And this guy is now ln negative ln absolute value of cosine x plus c. Again, make sure that these domains are the same. Okay, I'll show you in the next video in a little while. I'll upload that soon.